Dr. Christoph ROSER, I hope I got your pronunciation right. And you're there in Germany, and probably it is morning for you and breakfast time. And for me, it is lunchtime. And invariably, when I talk to speakers from US, it's their morning time and my dinner time. So I'm very happy that I got you during the daytime.
Yeah.
You have an amazing book that you brought out, Doctor.
Thank you.
And for Gemba guys like me, this is going to be our textbook. And I would recommend to everybody who really wants to do something on the shop floor in their Gemba, every chapter is, to my mind, gold dust. Everything, including the formulas that you're given for Kanban, the convip concept, and the basics. And you have not only restricted it to manufacturing, you have even extended it to health sector. And health sector is something that really requires lean and the pull system that you mentioned in this. And it's so exhaustive that you have covered it. So the first question to you, and this is impromptu, and you're just back from your holidays, so it is called the ramp-up time. So there you go, Doc. Why did you choose this topic when you have got so much to talk about, and you have written so much blog about Kaizen, and I don't miss any of your blogs, Doc. And thank you very much for being there for all of us in continuous improvement throughout the globe. We just look forward to all your blogs. It makes a lot of authentic stuff because you have spent over 5 years with the Toyota Central Research Development Laboratory at Nagoya, and then with your hands-on in Mckinsey and with Bosch. And my association Germans, we know that Germans believe in engineering marvels, and I know about it. So well, thank you very much for being my guest. And let's start by saying why focus only on full production system in the book.
Well, lean manufacturing and the Toyota production system is such a wide topic, and it has so many fields from maintenance to pull production to changeover to standards to just in time, just in sequence. And set up just the tools, not to even to mention the whole philosophies which go with it. So it is a huge field, and there are many books out there which write about lean in general. But for me, as a bottoms-up guy, as a practitioner, I often felt it's lacking some details, and I wanted to provide those details. I wanted to really help people working it on the shop floor and not just give a high-level overview and fly through of all the things there are, but I really wanted to go deep down and explain why this and how that. And there are many different topics I could have written about, and hopefully I will write about more topics. And you know my blog, allaboutlean.com, I write about many different topics. And now soon turning 10 years of my blog is soon turning 10 years old. But one topic I liked the most, or one approach, which for me is one of the cores of lean, is pull production. And that's why I decided to write my first book on lean about pull production and go into great detail, not only the Kanban system, but also the many different other systems there are, often much less known, and explaining why and how and what to avoid and how to make sometimes some compromises if the reality clashes with theory, and just try to go into great detail on pull production. And the book is very successful. It sells actually very well. I'm surprised how well it sells. It received the Shingo Publication Award. So it is a very successful book. But hopefully it's only the first book out of many. And I'm currently working on a second book. I'm actually halfway done with a book about work standards, which to me is another core topic on how to make lean, because work standards nail down how to actually do the work and prevent backsliding into an unstructured work. So work standards is also something very important. And many books mention work standards, but few of them go into detail. And hopefully my next book will be providing much help to the practitioners on how to do standards with many different examples and when to use standards, when not to use standards, and provide a lot of help. As I said, it's halfway done. I'm almost done with the first draft. So not sure when it will come out, but it's probably going to be called All About Work Standards, including also standard work and leadership standard work and other topics. And hopefully also helps people working on the shop floor, bottom up, roll up your sleeves to get the work done.
Yeah, Doc, that's something that is going to help us because many of us who are in the Gemba working with the workforce, many of these books, like the pull system, where you have gone into such details, it becomes more or less like a textbook. And I am hopeful that, and I'm trying to promote this in the Indian University too, that to use this for people who are talking about lean, to get this to the engineers, to understand what really pull means. Otherwise, basically, they talk about the philosophies, etc. But these youngsters who are there, who are actually going on the shop floor, working, as you said, roll up the sleeves and work, they should have the basic knowledge of what to use where. And you have provided in great details in this book. And I'm looking forward because you are the authority on that, and I'm just a practitioner, that if we have the standards, which you're going to talk about, the work standards, and people get really confused between the cycle times and how do you calculate the cycle time of the machine, how do you do the combination sheets. There are a lot of things that are written, but it is written very superficially. It is not written for a student who can follow that and implement it. And you are a hands-on person. So that would be of great help. And you are going subject-wise in depth. And that series would definitely help many of the boys who are doing their graduation in engineering or diploma engineering or even master's or doctorate in engineering. It'll be of great service to all of us across the world. I'm sure in India it will be of a great hit. So we are looking forward to that. And there is, I can talk in general, but in specific, the Toyota production system, and since I mentioned that when Iwata said that, we talk, we preach Toyota production system, but you have to adopt yourself according to your processes, your people, and your culture. So when the lean came into vogue and people started talking about lean, and somewhere it got distorted. Can you throw some light on?
Yes, just one of my recent blog posts was about the difference between the Toyota production system and lean manufacturing. And while in theory, lean tries to be the same, in reality, it's different. Some of those differences are, of course, based on the type of product and the company. Making cars is just different than if you make toothbrushes or so. But a bigger difference is the way it is done, the underlying philosophy, something which is really hard to nail down. At one point, I want to write a book about the lean philosophy, but it will be difficult to really nail it down. But at Toyota, it's usually the people on the shop floor or the people from the company doing the lean. So they know the system very well. And they have a culture of checking, does it actually work? The PDCA, I'm sure you're familiar with that. That's something integral to the Toyota production system to see if it actually works. Whereas in the Western world, not always, but often, lean is driven by consultants, and consultants come to a company and they don't know the product, they don't know the systems, they don't know the people, but still required to show results very quickly. And because of that, they often go for some tools. Like 5S is a very popular tool because afterwards the shop floor looks very different. If it's sustainable, that's by that time the consultant may be gone, but it's a lot of consultant-based lean, and they do things differently because they need to show some change quickly, but they're not there for the long term. So it's a little bit different behavior. Also different is not always, but often the management. That at Toyota, everybody at Toyota starts out in the manufacturing. If you join Toyota, it's usually a new employee right out of university. So the first half years they assemble cars. Part of it to have this to fill the summer gap where the normal employees are on holiday, but from there they rise up the ranks. But every one of them knows how to assemble cars because that's how they started their career at Toyota, and then they go to construction, design, or to sales, and move up to different areas, so they know the whole system very well. Whereas in the Western world, managers frequently change jobs, and a manager may be managing the production of tiles at one point, and a few years later he will be managing the production of soda bottles or something else. So they're often switching topics. They're not as familiar with the product as the people who have grown up with it. And they're using a more kind of MBA style of approach, management by numbers, kind of measure it, set targets, and then let your people work. But it often fails on the PDCA, plan, do, check, act. They set deadlines, and of course, faster deadlines makes better, supposedly faster changes, but in reality, faster deadlines often lead to the people don't allow cutting corners, and it will not end up as it's supposed to be. So basically, the two reasons: one is a more consultant-based approach, and the other one is a more MBA style approach where you learn management from the top down, which water down the lean versus the Toyota production system somewhat. Again, it's not everywhere. It's not always. There are lots of people also in the Western world which make good lean, both bottom up, but also in management. But there is somewhat a trend to value the tools over the philosophies and value numbers over actual performance.
Yeah, that I remember that one of the episodes that I did with Katie Anderson, that was when Yoshino-san had come, and he talked about this program called ConPro, where the senior managers of Toyota had the 2 years program where the youngsters who used to come up the rank did not have much knowledge about the culture. And they conducted the program, it's a 2 years program, which they conducted within the organization and not taking somebody from outside. So is there a culture in Toyota where these cultural aspects and these aspects are discussed as a mentor-mentee relationship in Toyota?
I definitely had a mentor. My boss, and I'm still in contact with him, even though he's now retired, helped me a lot. And it was a very different style of management from what I've experienced in Germany afterwards. In many Western companies, if there's a problem, you look for somebody to blame. Whereas at Toyota, it's more a search for solutions rather than a scapegoat. And in my 5 years at Toyota, I think I've never been blamed for anything. Whereas in my 5 years at Bosch, for example, every week somebody tried to push something on me, usually lack of materials or some other stuff. So it was a very different culture. And I think in Toyota, up to now, the culture is more cooperative, more working with each other, saving the Toyota culture again.
Yeah,
Yeah.
one of the things that I was quite amazed when Adobe spoke to me about when people are inducted into Toyota, they come in the batches, and they remain attached to each other more practically for the lifelong, and they learn
Mhm.
from each other. It is not only the formal but even informal, like the silos that we witness across the world. That's somehow in Toyota seems to diffuse. There's no verticals of quality production or whatever. They start learning from each other, even if it is not formal, in a cafeteria or even outside. And the family relates to each other. I wouldn't know whether what I hear is
Mhm.
correct or not. I mean, you are the authority on that. How the
It's
culture
part.
gets built up. So I'm not very sure whether uh, I hope the CEO doesn't make much of a change if the culture can succumb into the culture.
Well, in Japan, at least for large companies, there is kind of the tendency of lifelong employment. You join a company and you stay with it pretty much till retirement. It is slowly changing, but for large companies, it's still quite common. And for example, when I was at Toyota myself at the Toyota Research Laboratories, at one point during the 5 years I was there, one person of the research lab quit Toyota and joined another car company. And the managers were shocked and kind of, how can he leave Toyota? How can he leave the company and join another company? Because there it's the companies demand a lot. Working in Japan is not easy peasy, but they also try to provide for the employees. And the expectation at Toyota in Japan is if they hire somebody, he will stay with the company for till retirement. And because of that, they can put in much more time and effort in training and kind of teaching them. And the typical way, let's compare it with a Western company. If you're in a Western company, you're hired as a quality manager, and then you do quality, and maybe you become the quality department head or the head of quality company wide or something. But you stay in your quality silo, or you're hired as a production engineer. Then you do production, maybe at the bottom, and then goes a silo up. But you probably stay in the silo production. But at Toyota, you're not hired for a certain role, but you're hired as an employee of Toyota. And as I said before, you start with a few months actually assembling cars yourself, doing this assembly line and assembling cars. And then you go to a new area. Maybe it is quality or the development or purchasing or sales or something, and you work for a few years there. After that, you don't necessarily move up the silo, but you move to a different area. Maybe you go from quality to sales. And so as the people raise in hierarchy, they get a bigger and bigger picture of Toyota, and as the board of directors, with a few examples of people who come from the outside, but the kind of the people who lead Toyota usually know the many different areas of Toyota well. And that's an advantage compared to Western companies, where often people know their own silo very well and think their own silo is doing everything good, and also problems come from outside. That kind of the production has problems because of design, and the sale has problems because of production. But if you have actually been in those areas, you know those people try to do their work, and they have their own problems to deal. And it's not just throwing things over the fence for others to kind of take my problem, and it's not my problem anymore. But they know Toyota said the other people are also trying to work for the same goal, and sometimes there's some friction, and they know it because they've been there, and they try much more to solve the problems together instead of just pushing it off to another silo. So it's also one cultural difference at not only Toyota, but many other larger Japanese companies.
Yeah, because what you said resonates with what Ernie Richardson had told me. He was with Toyota in North America, and he came from IBM to Toyota, and he worked for 35 years over there. And he was looking after production, and one fine day he was moved over to look after the HR and the medical facilities over there. So
Mhm.
I just recollect or resonate precisely what he said, that so probably even in India or elsewhere, that if you're doing good in a particular function, you stay in the particular function and that's it, you don't move. But here you move across and take care of the other units. And what I liked about it is Ernie was telling me that, when he used to go to the Gemba, and I come to the Gemba walk part of it, is that when he goes to the Gemba, his supervisor used to ask him only 3 questions. The 3 questions were, he did an episode with me, which is called the leadership, I forget it. Okay. He talked about the leadership culture. He talked about the Toyota leadership culture, 10 points. One of the things that he said is that when he used to go to the Gemba walk, his supervisor, his immediate boss, would ask Ernie 3 things. Whom did you develop today? What did you learn? And how do you measure it? And Ernie used to tell me, and it is recorded, he said, I used to avoid the first couple of times. The minute I went to the Gemba walk and I came back, I used to avoid meeting the supervisor because I had to answer these 3 questions. But these 3 questions are so vital for those people who go to the Gemba walk. At whom did I develop today? What did I learn? And how do you measure it? Your take on that, Doc?
Yes. It probably goes back to Taichi Ono, who gave his people a lot of freedom and was more interested in improvement and understanding and learning. And their famous, for example, is the Ono Chalk Circle, where he took a young engineer on the shop floor, drew a circle with chalk on the floor, and told him, "Stand there, I'll be back in a couple of hours and see what you've seen." And the engineer then stood there and was observing a process for literally hours on end. After a while, Ono came back and asked him what he had seen, and the engineer explained. Ono asked a few questions very similar to the style you had, kind of what did you learn and kind of what would you improve. But then usually Ono was not yet satisfied, but gave him a few more hours, and it could easily be 1 or 2 hours, of course not continuously. He needs to go to the bathroom and have something to eat, but he would spend a lot of time just observing the process to really understand it in depth. And that's something very valuable. Of course, nowadays it would be difficult to do this. If you take an engineer in a company and kind of put him on one spot for a couple of hours, he's going to complain a lot, somewhat valid. But it is important to really understand a machine or a process. And that's one of the flaws many people make when they see a factory. They watch a process once, and then they think they understood it. But watching a process once tells you nothing about the deviations, about the fluctuations. Sometimes things go wrong, sometimes things go not so wrong, and you just need more time to understand how the process behaves with the fluctuation. And for improvement, the fluctuations are actually the bigger problem than just the quote normal operations. You need to understand all the things which can go wrong, which can happen, which can make smaller or not so small problems. And you don't see this if you watch the process only once or twice, making 1 or 2 parts, but you need to watch it for a longer period of times to understand in more depth and get kind of a feel for the process. And it takes a lot of time, but it makes it so much easier for you to actually improve not only the normal, so to say, operations, but to reduce fluctuations. And fluctuations are actually a much bigger problem than sort of normal waste, because a lot of waste follows on some fluctuation. Yeah.
Yeah. So when since you're writing on standards, and I'm quite curious about the standards, is when you have a standard work, and when is an operator permitted to fracture a standard, or change a standard, or he's never permitted, or if he has a brilliant Kaizen idea, when does he do it? To uplift the standard.
The standard is sort of a best practice, and it should be not too much detail, but also not too little details. That's often the difficult part with a standard. And it should describe how the worker is supposed to do his work. There may be sometimes problems. Is there some deviation, something is broken or so? Maybe at one point he can't follow the standard because there is an actual problem, maybe a bad part or something. Then he, hopefully with the help of his supervisor, should figure out what to do and also solve the problem so it doesn't happen again. But that's kind of a short-term fluctuation. And on that one, it just happens. You can't really avoid it. But on the longer run, maybe the operator will have an improvement idea, how to make it faster, better, cheaper. And that he should not deviate from the standard just by doing it differently. But instead, he should initiate a change of the standard. First, he, probably together with the supervisor or kind of the owner of the standard, he should try out, is it actually better, or is it does it create some problems later on for somebody else? So try out the standard, see if it's, try out the improvement, see if it actually works. And if it works, then they should update the standard and it becomes a new standard for everybody. If it doesn't work, he should revert back to the old standard, which is better than the improvement he tried. But it should always be grounded in standards. There are very few exceptions where it shouldn't be a standard, but usually any kind of repetitive work should have a standard, and the operator should not deviate unless there is an actual problem with some fluctuation or some broken parts. And for improvement, it should kind of be part of improving the standards, not just the operator thinking, that way is better, and now I just do it this way and deviate from the standard, but instead updates the standard.
So they probably do it offline, is it? And then they, if it works, then they incorporate it into the process?
How to update the standard? It's usually, depending on the change, it may be a shorter or a longer process, but you take the current standard, you try out the change, and if it's just something small, they can try it out right away. If it would need a new tool or a new machine or equipment or programming change, and I'm sure you know programming changes always take forever because an operator on the shop floor can't do it, and now you need more people who buy parts, make programming changes and so on. That will take longer, but ideally it's a small thing where you kind of just do one in front of the other instead of the other way around. That the operator can try out right away, and then the operator, with the support of his team, they should figure out, is it actually better? And if it is better, then they should update the standard accordingly to make a better standard. But it could happen ideally on the shop floor, unless it's a more complicated change where you need tools or programming.
They talk a lot about the operators. Now that we have just, you're going to write a book on this. I'm not going to steal anything away from your chapters from the book. So
no, you're adding to the chapters. I'm getting ideas for more chapters now.
The first thing is there's so much of controversy on the first thing of setting up a work standard. Now, Sensei Masakima had told me or taught me this thing of standard work is that we pick up the best process that is there available and to be done by the best operator over there. Okay, and that's what he told me. And then he said, look, initially there will be fluctuations, but then later on it stays. So even if you're making the standard, give it a time and see that that becomes a standard done by a particular operator. And then you publish it as a standard work. Now, there's a lot of controversy as to how you do it. That everything has to be ready, everything has to be done, and then only you introduce standard work. If everything has to be done and everything has to be in perfect, and then you do a standard work, I don't know how long will it take. So what's your take on how do you initiate in a new company or even an old company, initiating Kaizen, a lean, these days I call it lean TPS, is it helps me out, well, so that I have not caught either lean or TPS as a lean TPS. So
yes. Initially, assuming you start a new company or a new production line, you probably don't have any standards. In theory, you would just make all the standards and be done with it. But in reality, you don't have the resources to do everything. So how standards are created is you have to start at one point. You have to start with one process to make a standard. And you shouldn't pick just a random process. You should pick the one where the standard is most needed. So it could be a process which has quality issues or performance issues or time-wise issues or cost issues or something. But you should start with a process where a standard can give you the most benefits, the most bang for the buck. And then you should create a standard there. And over time, you should create standards for pretty much all repetitive processes. Same with improvement for standards. In theory, you should improve the kind of check the standards every, I don't know, 3 months, 6 months, pick a number depending on how hard you want to sound like. But in reality, you probably don't have the resources to look at every standard every 3 months to see if it's still good or to need to be changed. So in reality here too, for changing or improving the standard, maybe you have a problem. Maybe some equipment changes or a new product comes or something, and you must change the standard. So that's where you're more or less forced to update the standard. Or you see which process has the biggest potential or where an employee has an idea where it's easy to implement. So there are different ways to start the standard, but yeah, in reality, you have everything and do everything and you're perfect and it's wonderful. In theory, it's everything perfect and wonderful. In reality, it rarely is. And the number of problems you have on the shop floor pretty much always exceeds your ability to solve them. So you have to pick your fights, you pick your targets, and I usually go for a compromise between impact and effort. If it's small impact but small effort, I may do it just because it's easy peasy and it makes the operator feel good by having a small change for the betterment. But also some big projects with big impact, which need more time and efforts, that also has to be done because obviously it has big impact. So I'm usually going by an impact effort matrix and try to get a compromise of impact and effort and try to avoid the project which has a lot of work with little impact. That's basically the gist of it.
Yeah,
But
so
yeah,
the
have to start
impact,
somewhere.
yeah, the impact matrix would be a 4-quadrant one where you have the impact and the effort or time involved, and then you choose which of the quadrants you would like to operate on, right?
Yes, it's 2 axes. One axis is how much effort it is, and it's not always really measurable with numbers. I mean, you could put in the euro amount or the time amount or whatever, but usually it's just a gut feeling because you don't know the cost in the beginning anyway. So it's just a gut feeling. Is it easy? Is it hard? Where on the scale is it? And the other axis is how much does it benefit you? And that's even harder to measure because if you reduce fluctuations, it will be good for your company. But how much is really hard to say. But here too, you have some gut feeling if it's kind of something which has a big impact or small impact. And then you just put dots on this matrix with 2 axes and see which one you want to start with, which one is kind of a good compromise between impact and effort, and prioritize those which give you the most bang for the buck. And again, in theory, you could measure both axes. In reality, usually you can't. One axis you can't measure at all, and the other axis you can measure only very imprecisely. So I usually just go by gut feeling and have the people familiar with the topic estimate where on the axis they are in terms of impact and effort.
So let me just take you across to this of the ability to solve problems. One of the things that we talk about is the frontline supervisors, the frontline workers should have the ability to solve problems or structured problem solving, whether what's your take on that? I mean, how does the I mean, we talk about all the structured problem solving or 5 analysis or what have you. They do it at the shop floor, or they do it at the supervisors level, or team level, team managers level, or the higher supervisors level. Where do they? I'm sure the problem is spotted by the Gemba operator. But at what level does this problem get escalated? What is the escalation process?
It depends on the problem. They do improvement in all kinds of levels, and it depends on how many levels you need to involve. If you want to buy a new machine or so, you can't have the operator buy a new machine. So for that, you need to involve higher up management to kind of decide which machine to make get an offer, to make a purchase order, and that kind of stuff. So that bigger changes need more levels of hierarchy. Smaller changes can be done directly on the shop floor. If the operator decides my trash can, which usually stands here, maybe better stands here because I have to do one step less. That's the operator and maybe his team leader who decide, yeah, it's a good idea. We do it that way, and just move it around and have it done without the upper levels of hierarchy ever getting involved. Maybe they get informed at one point, we did this because it's better, but the level of involvement depends on the level of hierarchy. And ideally, the operator on the shop floor, possibly together with his team leader, can make small changes themselves. And yeah, of course, as soon as it involves a computer, you need more levels of hierarchy, because programming is always the enemy of fast improvement, because you always need more time to program and do changes to the computer system.
Do they still have a span of control for a team leader of 5 operators under them? Or
yes.
What would the span of control now? And is it still true that the supervisor is one of the skilled people who move up the level of supervisors? Or how is that hierarchy decided?
Yes. First of all, the word supervisor or group leader is used very differently in different companies. But at Toyota, a supervisor is on the shop floor. It may be different for engineering or other things, but on the shop floor in the assembly line, a supervisor is, team leader as it's called. A team leader is in charge of 4 or 5 people and a small segment of the assembly line. And the supervisor is usually risen from the rank of the operators. So he was an operator, usually very experienced, and knows the area very well. So he can help and he understands. He's kind of the most senior guy in the segment of this assembly line. But he originated from the assembly line because for his job, he needs to know this part of the assembly line very, very well to help the operators with problems. And the supervisor is there to support if there's problems, to kind of step in if an operator needs to go to a bathroom or something quickly, because you can't stop the line if somebody needs to go to the bathroom. There would be lots of headache. So he helps and supports and still often works on the line, and he's kind of an operator deluxe, so to say, and supports the operators on the shop floor. And above them, there's like group leaders, which is in charge of multiple team leaders and their teams. And yeah, but they still have a very small span of control on the shop floor for production. It's different, of course, in other areas. If it's like project management or purchasing, you don't need this tight level of support. But on an assembly line, if there's a problem, it can't wait. Because if the assembly line has a problem, then 500 people have a problem. Whereas like in purchasing, if there's one problem, it doesn't mean 500 people have a problem. but it has some more time for fixing. But at an assembly line, if they make a car every minute the problem means one car less. It means a couple hundred people standing around waiting for the problem to be fixed. So there is a lot of pressure to have a fast response system, and for this, Toyota needs this very high level of control. And I actually, in one of my blog posts, I looked at this. I compared efficiency versus span of control, because how tight should the span of control be? Should you have a team leader for 3 people, for 5 people, for 10 people, for 1 person, or how should it be? And in the Western world, usually they do a cost accounting approach, and they can calculate the cost of a team leader very easily. But they can't calculate the benefit, and so usually if they can't calculate the benefits, they set it to 0. And that's how we end up in Western world with like 25 operators on 1 supervisor, which is totally flooded with just managing them and has no time whatsoever to solve their problems anymore. And this shows in the performance. I actually looked at the efficiency and made some back of the envelope calculations. Actually, 3 to 5 operators per team leader is a good ratio to get kind of the overall best performance, including the additional time or the additional cost of the team leader.
Yeah, this since it's impromptu and my mind is moving up and down, is there's this question that occurs, and I do not know whether it is a Toyota culture that you have, that they are always looking for, like even when you're setting the standards, they said, if, the question of if comes in, that if something goes wrong, there's always the if factor that they always have in mind, even while setting up the standards, or even while solving the problem. That when they solve the problem, they always look at, if I take this countermeasure, what would be the impact on the total system per se? Is that a natural way of thinking in Toyota?
That's difficult.
How will it affect the system? Or I mean, I may be probably.
Well, it's generally a problem if you kind of a factory is a big complex machine, and if you turn 1 screw, maybe it has no effect on the rest of the machine, but there may be problems where situations where kind of changing 1 thing may lead to a problem further on downstream, which you didn't even think about it, and that can always happen. And sometimes you know about it if you think about it, but sometimes you just don't know about it and have to find out by trying it out. You try it out, and if it turns out it's not good, then you revert it or try a different approach. But it's always a risk that influencing 1 area may influence another area, maybe to the better or to the worse. Yeah, so it's difficult to answer.
Yeah, where I'm coming from is difficult to answer, but there has to be some level of hierarchy at some point of time that looks into the various changes. We may have a solution, and I'm talking it loud to you, Doc, is that we have the best solution, a point solution for that problem. But it may not be the best solution for the entire system, but it is a solution for that particular moment. And as you rightly said, at some point of time, it'll disturb certain other aspects. So we deal with it as we see it. If we can foresee it, great. If we can't foresee it, then we take it as it when it comes, right?
Yes, it's in academia we talk about the local optima. It's best for this area, but it may be worse for the other areas. And touching on an earlier topic you mentioned, Toyota may have an advantage on that one because of not being always in 1 silo. And if you're always in 1 silo, you know all the problems in your 1 silo, but you don't know how this will affect the other silos. Whereas at Toyota, if they have been in many different functions, they have often a much better understanding. If I do this, then I will create a problem later on for that one. And it helps actually with making better decisions.
Yes, I'm not getting into academia. Otherwise, I'd start talking about analysis and synthesis. So I will not get into that, at least in this episode. I'm going to catch you for next episode, whether it is 2024, 2025. I don't know where you go for your holidays, but come to India for a holiday. So then I can catch you over here. So let's move into another area, which is fascinating for me. And let's see your take on that. And I'm sure you'll give us gems and gold dust as usual.
I try.
Let's talk about technology. I know you did that in Factory 4.0, 5. I attended your session over there. We're talking about the Martek's law, when the technology is moving at the exponential rate and the organization is moving at a logarithmic rate, and both seems to be going at their own speed. And the gap that is produced between the exponential rate of growth of technology and the logarithmic rate of growth of organization, how do we fill up the gap? In the sense, I had covered this in a couple of episodes, and we know that the organization catches up the technology, what they require, but who knows? Because both are moving independently. Very often they pass by each other without really understanding what they're really doing. So your take on that?
Technology is moving very fast. We are entering a time period where there will be lots of changes. And there have been similar things before, like industrialization was a big change, and using computers in industry was a big change. But now with artificial intelligence, I think another change is ahead of it. And when I first started using ChatGPT at the beginning of this year, I was blown away at how good it is. It's still very flawed. It still makes lots of mistakes, but it's probably it can answer many questions better than my students could at my university. So it is a huge change. And it's to be seen how this will influence technology. I'm already using ChatGPT every now and then. I still write my blog posts myself, mind you, but I'm using it a little bit to help me structure my thoughts and summarize things. But it is a big change. How it will implement on the shop floor, we have to be seen, because ChatGPT is good with words. And there are similar programs which are good with pictures, like DALL-E or Stable Diffusion or so, which make you type what you want and it makes you a picture. It paints you a picture for it. It's also amazingly good. And they can do this because they have lots and lots of training data. So there's like, I'm not sure about that number, 50 gigabytes of, terabytes of text available, which is good and which is used for training. And the more training data you have, the better you can train systems. And there's terabytes of text, probably petabytes of images, which you can train for systems. But on a shop floor, it becomes much more difficult because you lack the training data. And even if you have the training data, it may not be applicable to the next factory. So on the shop floor, the use of artificial intelligence is still very limited. Sometimes it's found for like image recognition, but I don't know of any shop floor which dares to use AI to control its production, for example. At one point, it may come. At the moment, we still lack the training data. That will be the problem. And a lot of Industry 4.0 I've seen is just standard approaches up-talked into being fancy. And with Industry 4.0, it's always difficult, even for me, to understand, is it really an improvement? Or are they just talking about it being better and just pretend and try to sell common stuff as fancy new things? So with Industry 4.0, it has a lot of potential, but it is a mixed bag. It also has a lot of problems. because at the moment, one of the biggest issues I see is if you do a big computer project and kind of digitalize everything, it makes it really hard to change. So it will slow down improvement, and you will get stuck with a computer system which is less than optimal, has many problems, but nobody dares to change it because changing it would be a huge cost, lots of programming, and it would be unclear if at the beginning it would work really well, or it would kind of slow down your factory to a crawl for 6 months until you figured out all the problems. All of those things have happened, and it is a mixed bag. So I'm not against Industry 4.0, but I advise caution not to go overboard and not to do too much computers, because if your system is a chaos and you put it in a computer, it's still chaos, but it will be much harder to fix.
As you rightly said, probably a degree of flexibility will be lost because the time taken to rectify it. My concern is a slightly more hypothetical. And since you're in academia and I do stupidity in academia, only thing that I've never written a book, and I don't know if I'll ever write a book, is this, that, and I give you an example, since I've just undergone a surgery, and it was a robotic surgery, right? So now, there's a beautiful scan that is done, and the person who adds value is the doctor. But in between the scan and the doctor, there is an interpreter who interprets the image, what is produced over there, for the doctor to take a decision. Now, I mean, blow it up to the technology. You got a lot of technologies going around, and you have got a lot of CEOs and CFOs, which I have a big problem. And if time permits, I can talk about it. Is which one? And there is somebody, or there has to be another level over there that interprets what is good for you, what is not good for you, some sort of intervention, or some human beings over there starting putting another layer between the technology and the organization. I don't know, probably this is my fit of imagination, or we are just bringing another, and then, yeah, that's been a concern to me.
Well, in the medical field, it is very difficult because everybody is different and describes their symptoms different. And for a doctor to really figure out what the problem is a huge challenge. And then to fix it is also not easy. And doctors do make mistakes, many mistakes actually. And I'm not blaming doctors. It's just such a complicated, fixing humans is such a complicated field. So they do make many mistakes. Probably much more than we do in industry when we produce parts, because every part is the same and it's much easier to standardize. And I believe computers can help there too. And there are already systems online which are, for example, trained on X-rays to find cancer on chest X-rays, for example. And they do a good job, and often better than some doctors. And maybe in the near future, we will see systems where kind of your medical history is digitized, and there is a computer behind it or some logic behind it to check kind of if the doctor one doctor prescribes you one pill, another doctor prescribes you another pill. If those two medicaments clash, or if you have a history of problems with one medicament, the computer hopefully will in the future alert the doctor saying, be careful, it clashes with this medicament, or the patient has a history of allergy against this one or something, to help the doctors to make less mistakes. Or with the surgery, you said you had a robotic surgery. I assume it was still the doctor controlling the tools,
yes,
but maybe the tools itself help the doctor to kind of have a better field of vision, to kind of see inside your body where normally it would be hard to see, and have kind of some small tools, and maybe have some additional stabilities, kind of as a doctor's hand shakes a little bit, it doesn't shake inside. And he can do smaller surgeries, which would not have been possible before. And common nowadays already is kind of so surgery where you get 2 or 3 holes in your belly for the tools to go in, instead of getting a big cut all the way along. So the doctor can go in with its hands. So it makes it much less invasive. The recovery time is shorter. The survival likelihood is better. So those tools will help science, will improve the survivability. It will not fix everything, but I'm looking forward to medicine becoming even better than it is now, and hopefully for doctors to reduce the frequency of mistakes.
Yep. Yeah, that's true. And even the blood loss was hardly any, I mean, relatively. So and with the industry, I'm still wondering whether you require some people who interprets technology. Where is the organization going to meet the technology?
Mm-hmm. Difficult to say. It also depends on how much technology the organization is ready for. Every now and then I get questions, for example, from Pakistan or India, where they have fully mechanical, for example, looms or so. And they're asking me about Industry 4.0 when they use computers only for some bookkeeping, but don't have any computers on the shop floor to control the machines. Yeah. And in this case, it may be too much of a step because the company has to learn how to use the tools. You're a doctor, but you're not a medical doctor. Neither am I. I'm also a doctor, but not a medical doctor. So if I give you the best surgery tools on earth, it would be a disaster for whoever you operate on because you're not trained in using them. And similarly, an organization needs to learn how to use computers, needs to also to learn what computers are really capable of. Don't always believe the consultant or the vendor selling you the stuff with all the promises, but really understand what can it do, what can it not do, what are the problems with it. And that's not always easy for an organization to learn. And it's often learning by doing, and unfortunately also often learning by mistakes.
Let me come to the very curious question, since we have talked about technology, and I got two kids who are the next gen. They hardly speak to me, and they said, "Dad, send me a message, don't waste my time." So in the future, in the near future, are the CEOs and the senior managers ready for what I would call reverse mentoring? They start learning from the youngsters who are in the digital age and they are into technology, and they need to tell their CEOs, instead of mentoring, we have a reverse mentoring. Are they ready to go down and learn from these people? Like, for example, the chat that you said.
So you're basically asking a CEO to admit that he doesn't know everything. Good luck with that one. In many Western companies, being a CEO is on one part qualification, but on a probably even bigger part, appearance. To appear strong, to radiate confidence, to know the answer to every question. And in reality, they don't know all the questions. In reality, they're also insecure and worry about what they do right or wrong, with a few exceptions of people who don't worry at all, but I'm really worried about those people the most, who think they know everything, really. But as a CEO or generally upper level management, if you appear weak, then people will come for your chair and try to take over. So it is a bit an unfortunate situation where we often have CEOs which feel they need to know everything and need to have the answer to any question and need to know it better than everybody below them, which is not true and also not really good, but I don't have a solution to that one.
So they're not yet ready for reverse mentoring, learning from the youngsters who come in. How will they communicate then?
Well, I'm sure some CEOs will be able to learn, but a lot of them, it's difficult. Also, which youngster? Because if you're CEO, you have like 300 people telling you what they think is best. Which one is right? Which one is wrong? And it takes a lot of time, and they don't have the time. So it is not easy being a CEO. Actually, I don't want to be a CEO because it's too much work. But it is difficult. What helps is that as a company, you don't have to be great, you just have to be better than your competition to be successful. And the competition is usually not better in terms of leadership. They have similar problems and similar issues, so you don't need to be great, you just need to be better than the competition.
So, Doc, it was, as I said, impromptu, but I learned a lot from you, and that gives me more curiosity.
Likewise.
Of getting you engaged. And next year, I'm going to block you right from now so that you can help my study circle to understand this lovely book that you've written. And I would recommend to many of the universities that I know that if you want to know exactly, many of the organizations also, as a matter of fact, some of the second batch consists of a lot of CEOs and CFOs. So I'll ask them to buy this book, and this is really going to help them. And all the next books that you're going to write, and I wish you all the best. And
thank you
very much. If I am not structured, I think I'm very happy that I'm not structured, that I could take out a lot of things from there are a lot of more curiosities. I won't take your time. So because I have a lot of time, but the whole thing is my viewers don't have time. The youngsters don't have time to go through many of it. So thank you very much, and take care, stay well, and have a lovely week ahead of you.
It was my pleasure. Thank you very much too, and all the best.
Thanks a lot.
Bye.
Thank you very much. Take care.